Okay guys, today we are going to begin Chapter 8. We're going to talk about Section 8.1. Chapter 8 is all about something that we're going to call a confidence interval, okay? And I don't know where it went, but right here, this disappeared when I printed. This should say confidence interval. Our first objective is we want to be able to interpret a confidence interval and a confidence level. The word level disappeared, I guess, somehow when I printed it. Sorry. So the first thing we need to do, and we've talked about this a little bit already, is we need to talk about big general idea of what statistical inference is. Statistical inference is how we provide methods for drawing conclusions about a population from sample data. Okay? What kind of, we collect some data from a sample. Now, can we draw conclusions about the big population based on that? All right? When we're talking about collecting data and confidence intervals specifically, then what we're going to do is sometimes we have something called a point estimate. And your point estimate is what's the point, what number can we use to make an estimation for the whole population. Okay, what's our best guess? All right. If you have a sample mean, then that's your best guess, your best point estimate for your population mean. If I ask you all, how many siblings do you have? And you give me, and your average is 2.2, then I would say my best guess for the whole population of Seneca kids, average number of siblings, would also be 2.2. Okay? If you're dealing with proportions, then your sample proportion is going to be your best point estimate for a data set that's a population proportion P. Okay, now when we're talking about confidence intervals, before I even get into the details, let's just use like generic example. Okay, so how you can think of a confidence interval. If we're talking about an average, let's say we're talking about the average grade on a test, and I tell you that the average grade on a test is somewhere between a 70 and a 90. All right. So if I write this in interval this way, okay, with the less than symbols, it can also be written in interval notation this way, 70 to 90, okay, just like you have interval notation for like pre-calc and calculus and all that stuff, right? So if we have a confidence interval from 70 to 90, then what would you say is the middle, right? Your estimate for like your best guess. Well, I give you nice, easy numbers to work with. From 70 to 90, what's right in the middle of those? Right in the middle of those, our best point estimate would be x bar equals 80, because that's our sample average. You'll notice that 80, right, it's 10 lower is 70, 10 higher is 90. So when we're going through these next terms, here, your confidence interval is a specific interval estimate of a parameter determined by data used from a sample. I'm going to show you later in the next lesson how to come up with these numbers. Okay, today we just want to talk about identifying them and talking about them, all right? What we're going to do is how you get this is you can say it's your point estimate plus or minus your margin of error. This here, your point estimate was 80, your margin of error was 10. 10 points up, 10 points down. All right, it's the distance from your center above and below to get there. Now, in statistics, we don't have cute little whole numbers like that, right? We're going to have all sorts of decimals. But for the basic idea today to get started, we're going to use that. Your confidence also depends, right? It's called a confidence level. So your confidence is how certain you are of something. We have three basic confidence levels. We deal often with 90, 95, and 99% confidence. So these are the three main confidence levels, okay? The more certain you are, okay, we'll talk about how the intervals change depending on things, and we'll go through all that. This is usually given to you, like conduct a 90% confidence level, conduct a 95% confidence level. So typically that's told to you. These are the three main ones. You can use lots of others, any of them really, but those are the biggies we want. We want to be 90% confident in our answer. We want to be 95% confident, or we want to be 99% confident in our answer. This is big, and you want to make a note here for this bullet here. If you're asked to interpret a confidence level, whatever it would be, an interval, for an unknown parameter, then you're going to use this general statement to explain it. And I'm going to walk you through as I do some examples as well. Absolutely. So if you're interpreting a confidence interval, then what you're going to say is we are 90% confident that the interval from 70 to 90, right? If we use this example, you could plug in 70 to 90, captures the, and then parameter and context would be, for this problem, this was the true average grade on a test, because we had started with this as an average on a test. So we could describe it that way, all right? And I will come back to this, I promise. Now, if you take a look here, this is actually a picture from your book. But what happens is, let's say you're gonna take 100 samples, for example, and you make 100 different confidence intervals using 95% confidence, all right? So what happens is when you're thinking about that 95% confident, that means that 5% of the time we're gonna be wrong. We can collect data and make predictions, but that doesn't always mean that the predictions we make are right. We can still make mistakes. But if you're 95% confident, that means that only 5% of the time you should be wrong, or we would expect to be wrong. So if we had 100 intervals, then I used 100 because it's nice with 95%, we would expect 5 of them to not capture the true. So let's say that this line mu is the truth, the true average. Do you see how this interval actually contains the truth, and this one contains the truth, and this one, and this one, but then this one does not contain the truth? It's okay that this sample, the estimate was right in the middle. Your point estimate is the center dot on all of these. This one, your point estimate was too high, which meant your whole interval was too high for the mean, and that's okay. Now, there aren't 100 here, but if you drew 100 of them, right, then you would expect 5 of them to either be completely too high or completely too low. But the other 95 should capture the truth, okay, that the truth would be somewhere in that interval. It's okay if the truth is 89 here and 90 barely, like it barely makes it in, or 70.5 or 71. But as long as it's in between, it's in between. Or if it's out, it's out. Now, let's go through some stuff, okay? Example 2. A large company is concerned that many of its employees are in poor physical condition, which can result in decreased productivity. To determine how many steps each employee takes per day, on average, the company provides a pedometer to 50 randomly selected employees to use for a 24-hour period. After collecting the data, the company statistician reports a 95% confidence interval of 45-47 steps to 84-73 steps. So we want to first interpret the confidence interval. So that's going back to here, where we're going to use this basic kind of a sentence. All right, and I apologize that these aren't copied front to back. I asked for them to be copied and they didn't come out that way. So we are plugging in the context from that canned sentence on the front. So we are 95% confident that the interval from 45-47 to 84-73 captures the true mean number of steps taken per day by these employees. That's what we're looking for. We're pretty certain. Now, this is a wide gap, right? That's pretty big. Question 2 says, what's your point estimate? How can you find, remember how the 70 to 90, our point estimate was 80 right in the middle? So you just want to find the middle of these two numbers, okay? And then the margin of error is how much higher or lower it is. So I found that my midpoint is going to be 65-10, okay, because I did the average of those two, okay, to get there. Does that make sense? Like I took the low, I took the high, I added them together, divided by 2. The midpoint or the average is going to get me the middle of those numbers, which means that if you look at 65-10, how much do you have to go up to get to 84-73, or how much do you have to go down to get to 45-47? I forgot to compute this, so 84-73 minus 65-10 would mean that my margin of error is 1963. This is my point estimate. 1963 is my margin of error. 1963 up, 1963 down. Okay, and then part C, recent guidelines suggest that people aim for 10,000 steps per day. is there convincing evidence that the employees of this company are not meeting the guideline? Well, look, we're 95% certain that the true average is somewhere between 4,500 and 8,500 steps. So can we say that they're getting 10,000? No, right? We're pretty certain it's way less than 10,000. So we would say not only is it outside the interval, but it's too high. The whole interval is lower than the 10,000, which means it's probable that the employees aren't meeting this guideline. Sometimes being above the interval or below the interval is good. Depends on the context. Here, we're pretty certain they're getting way less steps than what they're supposed to. All right? So that's interpreting a confidence interval. All right? Now we also want to talk about interpreting a confidence level. So this is the other big deal. If you're interpreting the confidence level, then how we're going to describe that is we're going to say, for instance, if we take many samples of the same size from the same population, about 95% of those intervals will result in an interval that captures the actual parameter value. Right? And I made a note here that's a biggie. You only need to do this when you're specifically asked to interpret the confidence level. Usually, you're interpreting the interval like what I just did above. So if it asks you to specifically interpret the confidence level, then this is the interpretation we use. Usually, it's going to say interpret the confidence interval here. Okay, so if you think about this problem, according to a Gallup poll from August of 2010, the 95% confidence interval for the true proportion of Americans who approved of the job Barack Obama was doing as president at that time was 0.44 plus or minus 0.03. So we want to interpret both the interval and the level. So your interval is what we've already practiced. All right, so if you want, you can pause, try to write out your interval, and then check against me. All right, we're 95% confident that the true proportion of Americans who approve of the job Obama was doing at the time was between 0.41 and 0.47. I just took the 44 and added and subtracted the 3. Okay. Your level is what I just modeled for you here at this bullet. That matches this. So in 95% of all possible samples of the same size, the resulting interval will capture the true proportion of Americans who approved of the job Obama was doing at the time. So if you keep repeating your samples, then 95% of the intervals from those samples will actually capture the true proportion. Okay? So now, this is where you really do, right? On the honor system, because I'm not watching you, but you need to practice, right? You can't just wing this. So right now, number 4, you read this and do the interval and the level. Pause, set them both up, okay? And then check your work here. I have for my interval, we're 95% confident that the interval from 58,711 to 59,147 captures the true median income for households in Texas. And this is if many samples of the same sample size of Texas households were selected, the resulting intervals would capture the true median income of Texas households, about 95% of those samples. If you have questions, make a note to yourself, and then we could talk about them tomorrow or the next time I see you. So now let's figure out how your sample size and your confidence level are going to affect the width of an interval, length or width. I actually think I like the word width better. So your confidence interval, in sections 8.2 and 8.3, we go into the details of the calculations. But right now, we're just talking about going through the basics. So we really need to think about what's going to go on here, okay? This is your sample statistic. This is written on your formula card, right in the Roman numeral 3 part. Your statistic is like your X bar, okay? Your critical value, I'm going to explain to you later, but it's a multiplier. This number changes based on your confidence interval, the confidence level, sorry. The bigger your confidence level, the bigger your critical value is. And then this is your standard deviation of your statistic. another way you can think of it as this is your statistic plus or minus your margin of error, which I think was actually on a previous page, because your margin of error is going to be like what you're adding and subtracting to the middle. Okay, and again, your critical value is going to go up. It gets to be a bigger number as your confidence level goes up. So if your confidence level goes down, your critical value goes down, which makes it a smaller multiplier. So your margin of error is going to get smaller, which means the interval gets more narrow or narrower. Okay. When there's two ways this can happen. One is what I was just talking about, as your confidence level decreases. All right, because your lower confidence level means you're going to have a smaller critical value. And then it's going to not add and subtract as much, so it'll be a narrower answer. Okay. Number two, the other way this can happen is if your margin of error can also get smaller as your sample size increases. Because the bigger you ask, right, the bigger your data set is, your sample, then the more accurate your data is. Well, if the more accurate your answer is, that means your interval is going to get narrower, closer together, so that because your results are going to center closer to that center point. Okay, your larger N means you have a smaller margin of error. So, on the next page, you've got a practice problem to try. Okay, I'd like you guys to try number 5. There are 4 pieces to this problem. You hopefully will be able to answer them all as you cruise through. Okay, so pause the video right now. Try parts A, B, C, D. All right, and then hopefully you unpause. It's been a few minutes. And here are my answers. Okay, your interval, here's the interpretation. Your level, here's the interpretation. Your point estimate, I took the higher and the lower, I averaged them together to get my point estimate. And then my margin of error, I just took the highest point and subtracted the point estimate from it, right? So if my interval was 0.175 to 0.225, and 0.2 is right in the middle, remember that's how much you go up and down. That's your margin of error, your wiggle room. Okay, and then I had, yes, the interval is lower than 0.25, meaning that less than 25% of all U.S. adults would answer this question correctly. So if, our interval was from 17.5% to 22.5%. So we're saying that the truth is that less than a quarter of the U.S. adults would answer that question correctly, because based on the results we found. This time it made sense to be lower. Okay, it was a good thing. So we will talk about this later, and if you have time, get started on these problems. I will officially let you know via Google Classroom when you have to, if we're working on them in class or not. But like always, you can always get started practicing. Good job today.